Hello everyone. In today's video, I'm going to explain alcohols. Alcohols are those compounds in which OH is present as a functional group. So if you draw the first four structures, let's see them. So here you can see the structures with carbon 1 with one OH, and there are two carbons, then we got three, and so on. And their uh, molecular and structural formula. Here you can see this is the molecular formula CH3OH, and this is the structural one, and this is the displayed one. But it's not fully displayed. Fully displayed formula, we have to draw it like this, that you have to uh, remove this H from here and write it like this. So then it will be a fully displayed formula. We can make this formula as CH4O as well. It can be converted, like it can be made C2H6O, it can be C3H8O. So there are two types of general formulas that we can work it out from these molecular formula. The first one is CnH2n plus 1 OH, while the second one corresponding to these formulas, it would be CnH2n plus 2 and O. So these are two general formulas for these alcohols. So you see, as you go down this list, the molecular size is increasing, and with increasing molecular size, the melting and boiling points, they increase as you move down in this list. You can notice that the names of alcohols, carbon 1 is methanol, ol is the ending, eth for 2, ol is alcohol, prop for 3, and there is ol and butane and ol. Similarly, we can draw bigger structures as well, like pentanol, hexanol, etc. But all of them, they end with ol, and according to the general formula, you can construct any structure. Now let's see the methods for the preparation of alcohols. Okay, we can have alcohols that contain more than one carbon, like you can have two carbon alcohol in which there are present two OH groups. So such compounds, they are also considered as alcohols. They contain two OH, but such alcohols will not follow the general formulas of any of these, but they are alcohol because they contain OH groups. Remember, with increasing molecular size, the MR increasing, there's an increasing intermolecular force, and there is an increase in, like, the properties like melting point, boiling point, density, and viscosity. These are the properties that increase as you go down this list, while flammability and volatility, they decrease. Now let's see the methods for the preparation of alcohols. So we have to see the preparation of ethanol. The first method to prepare ethanol is by the fermentation of glucose. Glucose, is C6H12O6. So we can ferment. Fermentation is a process in which sugars, they are converted into the alcohols with the help of yeast, and this process takes place in the absence of oxygen. So we got C6H12O6. It produce C2H5OH plus CO2 is released. Well, this reaction requires yeast, and there has to be the absence of air. Other conditions, they can be like water must be present, and you need a room temperature, because otherwise yeast is a fungus that would be killed. So under these conditions, we get alcohol. Okay, this method, it has some advantages. The advantages is that glucose is a renewable source. And second advantage of this method, that it is a cheap method. It's not costly. Okay, while there are disadvantages at the same time. And what are they? It is a slow process, takes a long time, and produce impure ethanol. So ethanol produced in this process is not pure. So this is the first method to make the glucose, that is the fermentation. Now let's see the second method. Second method is the, you can say, the reaction of ethene with steam. So if you react ethene with steam, ethene, you know, is C double bond C, H2 and H2. This is ethene. And if you react it with steam, steam is H2O gas. This is also a gas. And this is a reversible process which requires the conditions, that is phosphoric acid is used as catalyst, phosphoric acid, and the temperature is 300 degrees Celsius while 60 to 70 atmospheric pressure. What happens? That we get C2H5OH. How it happens? Let's see in detail here. That we got alkene like this, and when you add steam into it, steam is HOH. Now what happens? That this hydrogen, it adds over here, the OH adds over here. The double bond is converted to the single bond. So what we get over here is like this. You get CH2, and there'll be a single covalent bond. Hydrogen is added over here and OH is added over here. So it is CH3CH2OH, or ethanol. Okay, now this method has got its own advantages. The advantages is that it's a fast process, requires, it takes less time to complete, and second advantage is that pure ethanol is obtained. Pure ethanol is produced. Okay, now the disadvantages of the method, they are two disadvantages. One is that ethene is non-renewable. Actually ethene is obtained from petroleum, and that's why it's non-renewable. And second thing is that this method is costly. So these are the two methods for the preparation of ethanol by the fermentation of alcohol, fermentation of glucose, sorry, and the reaction of ethene with steam, their advantages and disadvantages. Okay, now let's move and see the reactions of alcohols. There are two reactions of alcohols that we have to see. So the two reactions, one is the combustion and second is the oxidation. Let's see. The first one is the combustion of alcohols. So you can burn any alcohol. We got like C2H5OH, and it reacts with oxygen and it gives you CO2 plus H2O. Let's balance. Write two carbons over here, 5 plus 1, 6 hydrogens, write 3 here, and then we got, so we got 4 plus 3, 7 oxygens on the right side. So you will write 3 here to make it 6 plus 1, 7. Okay, so similarly any alcohol, it can be burnt to give you carbon dioxide and water. And ethanol is a renewable fuel because we can obtain it from the glucose. Okay, so this is the combustion reaction. Number two reaction is the oxidation reaction. Alcohols can be oxidized, and there are two ways to oxidize alcohol. The one is by air. If alcohol is kept in air for long, it will be oxidized and it will be changed into vinegar. So you got, let's say, C2H5OH is ethanol, and you react with oxygen. Uh, Remember, we are not burning it, we are not igniting it. There is no flame in this case. So it will be converted into the carboxylic acid. And carboxylic acid is, is a compound that contains COOH functional group. So since there are two carbons, we get a two carbon carboxylic acid. That will be, if you construct the structure of this carboxylic acid will be like this: CH3 COOH. So we can write it like this: CH3 COOH, and along with we get H2O. So this is the oxidation of alcohol, and this is the ethanoic acid, and ethanoic acid is a part of vinegar. Now there is another oxidation reaction, number two. Second way is by acidified K2Cr2O7. So K2Cr2O7 is an oxidizing agent, and it's orange in color. So acidified means that we will have potassium dichromate aqueous, and you will add acid like sulfuric acid into it. So it acts as an oxidizing agent. Now let's construct the equation. Equation C2H5OH. It's the same reaction, but in this case we are taking atomic oxygen that is coming from the oxidizing agent. The same reaction, we get the same product, CH3COOH plus H2O. Only difference is this oxygen, and we will have a potassium dichromate as an oxidizing agent. Potassium dichromate changes from orange to green. So these are two reactions of alcohols. Now let's see some more complicated uh, compound. For example, we can have C4H9OH. So if you oxidize it, what alcohol you will get, what carboxylic acid will you get? Now the carboxylic acid should have four carbons into it. Okay, so four carbons along with the carboxyl group. So carboxyl is COOH. Now in this carboxyl we already got one carbon, so that means we are left with three more carbons over here. So it will be C3 and H will be 7, because carboxylic acid, they have a general formula CnH2n plus 1 COOH. So if we have one carbon over here, we will left with three more carbons over here, and along with, if three carbons are there, then we have to have 7H along with that. So plus water. So any alcohol, it can be oxidized to form the appropriate carboxylic acid, and you need to just construct the formula. Remember that acidified potassium dichromate require heating. So these are the two reactions of alcohol, the combustion and the oxidation. Now let's see the isomerism in alcohols. So isomerism means the compounds having the same molecular formula but different structural formula. So we can have isomers of propanol. Propanol has three carbons. So if you have three carbons, OH can be over here on carbon number 1. So this alcohol, it is known as 1-propanol. Why 1-propanol? Because OH is on carbon number 1 over here. This carbon is carbon number 1, carbon number 2, and carbon number 3. So this is 1-propanol. We can have second isomer that contain 3 carbons and OH over here in the center, and this is called as 2-propanol. Okay, so these are two isomers of propanol. Then let's see isomers of the bigger alcohol like butanol. So in case of butanol, the first isomer that we can construct is 4 carbons with OH over here at the first carbon. Okay, the next one is that we can have 4 carbons, OH on the second carbon like this. If you make OH over here, that will also be the same, because in this case carbon counting starts from this side, carbon number 2 here, and in this case carbon number 2 is over here. So they are the same, no difference. Now we can have a branched alcohol as well. You can have 3 carbon like this and make 1 carbon over here. So and place the OH like this. So that will be another isomer, third isomer of alcohol. And the fourth one, it can be make a branch structure and make OH over here. So these are the 4 isomers of butanol. So next thing that we need to know about alcohols is the uses. So there are few uses of alcohols. First of all, uses of ethanol we have to know actually. So the first use of ethanol is that it is used as a solvent. Number 2, it is used to make vinegar. And number 3, it is used as a renewable source of energy or renewable fuel. So these are the 3 uses, and this is all about the alcohol. We have seen the structures, we have seen its properties, the reactions, preparations, structures, isomers, and the uses. Now let's solve some questions related to this topic. So the first question we have is that describe the manufacture of ethanol starting from glucose. Include an equation and the conditions needed. So we have just done this, that it's a fermentation method in which glucose is converted into the alcohols with the help of yeast, and the reaction takes place at room temperature. You need absence of air. That is the conditions. The conditions are yeast, absence of air, and you can write water, you can write room temperature. There are many conditions you can write from, but most important ones are yeast and absence of air. And glucose is C6H12O6 converted to ethanol. Now look at this question in which they're saying that ethene react with steam to give ethanol. Two conditions for this. So the condition for this is H3PO4, that is phosphoric acid, is used as catalyst. The temperature is 300 degrees Celsius and 60 to 70 atmospheric pressure is required for this reaction to take place. So look at this question in which alcohol, a list of alcohols are given to you. They're saying which group of atoms, functional group, must be present in the homologous use of alcohols. You know, OH is the compulsory part, is a functional group of alcohols. Name the alcohol with molecular formula C3H8O. C3, is prop, and alcohols they have they're named like as propanol. Deduce the general formula of an alcohol. General formula. So using these formulas, we can construct the general formula, that is CnH2n plus 2 and O. Now, a molecule of decanol has 10 carbon atoms. What is the molecular formula of decanol? So decanol will be C10 and H would be 22 and O. It is difficult to estimate the melting point. So whenever such questions comes, you have to see the trend. Since it is difficult to estimate the melting point, in the melting point you will find that there is no regular trend in the melting point. So since it is first of all decreasing, then it is increasing, so we cannot predict. While in the density there is a regular trend. So ethanol reacts with oxygen and air to form ethanoic acid. Describe another method by which ethanol can be converted into ethanoic acid. So the second method we have just done in the lecture, that is oxidation using potassium dichromate. So it is actually you can say using acidified potassium dichromate, which act as an oxidizing agent. So we have to heat. So we have to heat over here. Now butanol can burn in a limited air. So when there is limited air, we get carbon monoxide gas plus water. Combustion may take place in limited air as well to give you carbon monoxide and water. So in this question we are given with a reaction of alcohol with sodium metal, and they are asked to construct the reaction of butane 1-ol with potassium. So similar reaction we have to construct. There's nothing new, but we just have to different formula. So butanol is C4H9OH. It will react with potassium and it will give you C4H9ONOK plus H2. So on the similar equation, we have constructed this equation. So balancing will also be the same. There's no change. So that is your equation. You have constructed this equation with the help of this given equation. Now look at this question. Deduce the formula of sixth member of alcohol. So sixth member, you can see the general formula is C5H11OH. So we can write C6H13OH. So, two consecutive members in a homologous series differ by CH2 group. So we have added one carbon and two hydrogens. We can predict the boiling point of this alcohol. It would be an increasing trend. So there is an increase of almost like 20. So the next it should be like 158 would be fine, I think. So predict. So this always have a big range in which you can predict. So same question, fermentation, that we have just solved before. Suitable oxidation we have just done. Deduce the molecular formula of alcohol having 8 carbon atoms. So 8 carbon will be C8, H should be 8 times 2, 16 plus 1, 17, and then OH. Again the same, how the boiling point change with the number of carbon atoms in the alcohols, you can say the boiling point is increasing. So estimate the density of butanol. We have to estimate the density so that you can find the average of these two, you will get the density of this. So what's the physical state of pentanol at room temperature? and pressure. Pentanol, let's see. Pentanol has a boiling point of 117, melting point this one. The room temperature is 25 degrees Celsius, that is between the two. So we can say pentanol will be a liquid. And you will say that its melting point uh, is higher, so melting point is lower than 25 and boiling point is greater than 1, uh, greater than 25. How the viscosity changes? We know viscosity, it change as you go down the list. The intermolecular forces become stronger and as a result viscosity increase. So viscosity will increase as you go down the list. It's because of increasing molecular size which have stronger intermolecular forces. So greater viscosity, increasing molecular size, and greater intermolecular forces. So then we have to construct the equation for complete combustion of propanol. C3H7OH plus O2, it gives you carbon dioxide plus water. So balance, write 3 here, then 7 plus 1 8, so write 4 here, and now we'll have 6 plus 4 10. So we'll have to write 9 by 2 here because we already got one oxygen over here. Okay, same question, oxidizing agent. So conditions actually we have to heat it, and the oxidizing agent is acidified potassium dichromate. Look at these two questions in which they're saying draw the structure of alcohol that is an isomer of butanol. So butanol is, you can say, is a 4 carbon compound. So we can make carbon like this and then OH over here and complete the valencies with the hydrogen like this. So that will be the structure of an isomer of butanol. Next is butanol can be converted into alkene by the loss of water molecule. Draw the structure of an alkene. So you need to know alkene, which contain carbon-carbon double bond, and butane. Butanol will produce butene. Butene should have 4 carbons. So we can put a double bond. Anywhere you can put, like over here, no problem in it. So then you will complete the valencies like this.